questions 11 through 20 on the 2010 Grade 10 Cayley Math Contest. If x and y are positive integers with x plus y equal to 31, then the largest possible value of xy is x plus y is 31, and we have to maximize xy. So we just have to choose some values for x and y and kind of see what we get. Well, in order to maximize xy, I have to choose x and y that are close together. So for example, 16 and 15. That's as close as you can get if you consider the fact that these have to be positive integers. And if you multiply x times y, you get 240. Well, let's see. That is one of the answer choices, but let's see if there's any others that give us a larger number. How about 17 and 14? That adds up to 31, but then the product will be 238. So that's not anything bigger. How about 18 and 13? The product there is 234. So as you can see, the numbers are getting smaller. So the largest possible product for xy, such that x plus y is 31, is 240. So the number 11, the answer is indeed A. The price of each item at Gauss Gadget Store has been reduced by 20% from its original price. An MP3 player has a sale price of $112. What would be the same MP3 player sell for if it was on sale for 30% off of its original price? So when you took 20% off the original price, which I will let be equal to x, you get 112. So solving, you get x is equal to 112 over 0.8, and therefore x is equal to 140. So the original price was 140. Now we are taking 30% off, so 0.7 times x, which is 140, and that is 98. So this is the price when you take 30% off the original price. So number 12, the answer is $98, which is E. In the diagram, the smaller circles touch the larger circle and touch each other at the center of the larger circle. The radius of the larger circle is 6. What is the area of the shaded region? Area of the shaded region, AS, is going to be the big circle, pi r squared, minus 2 of the small circle, so pi small r squared. Now the big circle, they tell you in this question that the radius is 6, so I can immediately plug that in. But what about the small r? Well, if you draw a line from one end to another, that full line represents the diameter of the large circle. And that is going to be 6 times 6, right? Because the radius is 6. So that's 12. But from the middle point, which is right here, to there, that's 6. So that means that the diameter of the small circle is 6. So that means the radius of the small circle is 3. So 3 goes here. So this becomes 36 pi, and this is 9 times 2, 18 pi. So therefore this is going to be 18 pi for the area of the shaded region. So number 13, the answer is D. How many ordered pairs AB of positive integers satisfy a² plus b² equals 50? So we can make a little table and start plugging in values for x, or for a, I should say, and b, and see what happens. So they're positive integers, so our choices are kind of limited. For a and b, and then a² plus b² being 50, we only have a few choices. So the smallest integer I can start with was 1. If a is 1 and I sub it into this equation, I'll get b equal to 7. If a is 2, I get b equal to the root of 46, and that's not an integer. They have to both be integers, a and b. 3 for a would give me root 41, and 4 would give me root 34. 5 would give me 5, so that is a good one. 6 would give me root 14, and 7 would give me 1. And then if you keep going, if you use the same sort of system for B, it would be the exact same answers for A, because this is pretty much the same whether you put A or B. So the only integer ordered pairs are this guy, and this guy. So there's only 3 of them. So number 14, the answer is C. A loonie is a $1 coin, and a dime is a 0.1 10-cent coin. One loonie has the same mass as 4 dimes. A bag of dimes has the same mass as a bag of loonies. The coins in the bag of loonies are worth $400 in total. How much are the coins in the bag of dimes worth? The mass, not the value of the coins, but the mass has the following property that loonies over dimes are in the ratio 1 to 4. One loonie has the same mass as 4 dimes. So if you have one loonie, you're going to have 4 dimes. And that's why this is the ratio. And then they tell me that I've got 2 coins, 2 bags rather, and one has all these dimes in it, and one has all these loonies. And the bag with the loonies is worth $400 in terms of its value. So since each loonie is $1, that means there's 400 of these loonies in there, right? Because each is $1, and therefore the total value is $400. So then we go right back to this to figure out the number of dimes. So L over D is 1 over 4. So L is 400, and therefore this is D. Cross multiply, and you get D is equal to 1,600. So that means the number of dimes in this bag are 1,600. And they want you to figure out the value. Well, 1,600 times the value of each dime, which is $0.1, and that would be a total of $160 for the dimes in the bag. So number 15, the answer is C. The odd numbers from 5 to 21 are used to build a 3 by 3 magic square. In a magic square, the numbers in each row, the numbers in each column, and the numbers on each diagonal have the same sum. If 5, 9, and 17 are placed as shown, what is the value of x? We have all the numbers that are odd from 5 to 21. So let's write them all out. And then we have already used a few of them. So the 9's already been used, the 5, and the 17. So we have to fill these all in to make this match. Well, the first thing I want to do is add up all these guys. And if I do, I get a sum of 117 when you add up all those numbers. And that means that if you were to divide by 3, it would give you the sum of any of the rows or any of the columns. And if you do that, 117 divided by 3 is 39. So that means that any of these rows or columns add up to 39. So I can quickly figure this out. And this one, for example, if this is y, that means 9 plus y plus 17 is 39. And therefore y is 13. So instead of that y, I can just put in 13. And I'll circle 13 here to show that it's already been taken. And then in a very similar way, if this is z, I can figure out what z is pretty quickly. 5 plus 13 plus z is also equal to 39. So therefore z is 21. So instead of z, I can put in 21, and then I'll circle the 21 here. And then you just keep going like this. At this point, though, you got to do a little bit of fiddling around because this one, there's 2 missing. So 21 has already been used, so that means the other 2 have to add up to 39 minus 21, right? And that is 18. So of the remaining numbers, 2 of them have to add up to 18. And the only way, of course, is these 2 guys, 7 and 11. So I've got a choice. Either I put the 11 here or I put the 11 here. And if you put the 11 here and the 7 here, that's the only way this is all going to work out. And you'll see that the 19 will end up going there and the 15 will go here. That's the only way that this magic square can work. So therefore, x is equal to 11. So number 16, the answer is B. In the diagram, the number line is marked at consecutive integers, but the numbers themselves are not shown. The 4 larger dots represent 2 numbers that are multiples of 3 and 2 numbers that are multiples of 5. Which point represents a number which is a multiple of 15? We have to do just a whole bunch of fiddling around here, to be honest. I don't think there's any real technique. We have to say, okay, well, one of these is going to be a multiple of 15, right? So if somewhere in here there's a 15, then can I get 2 numbers that are 2 apart that are multiples of 3 and 5? And that's pretty much the story here. And also, this number is not necessarily 15. It could be a multiple of 15, right? 30, 45, 60. So let's just see. I'm not sure, so I'm just going to play around with this. 15 is somewhere in here, or some multiple of 15. So let's just see here. The numbers are 16, 17, going this way, 18, 19, 20, 21, and so on, right? And then going this way, it would be 14, 13, 12, 11, 10, 9, and so on, right? So these big circles are differing by 2, and one is divisible by 3, and one is divisible by 5. Can this work? Well, I can see here, right here, this is divisible by 3, and this is divisible by 5. So if this is 18, and this is 20, then that would work. So that would mean this is 17, this is 16, so the D is 15. Okay, but that's only half of the story. I've got to also make sure the other half works out. These two guys, one has to be divisible by 3 and one has to be divisible by 5. All right, counting backwards, we got 14, 13, 12, 11, 10, and 9. Well, 9 is divisible by 3 and 10 is divisible by 5. So there we go. We got 2 numbers divisible by 3, namely 9 and 18, and 2 numbers divisible by 5, namely 10 and 20, and the 15 matched with the letter D. So number 17, the answer is D. In the diagram, R is the point of intersection of P, T, and QS. If PQ is equal to PR and RS is equal to RT, if PQ is equal to 2x, then the measure of RST in degrees is. Well, first and foremost, this is an isosceles triangle. So that means if this is 2x, this has to also be 2x. Now, opposite angles are equal, so if this is 2x, then that is 2x right here. And then again, we have another isosceles triangle, so that means that these two are the same. I'll call them y and y. And therefore, in that triangle, 2x plus 2y is equal to 180. Isolating for y, well, first we can divide through by 2. And then isolating for y, you get 90 minus x for y. And y is the measure of angle RST. RST. So that is 90 minus x. So number 18, the answer is E. How many 3-digit positive integers have exactly 1 even digit? Well, my 3-digit number, I have 3 possible scenarios because I can only have 1 even digit. Emphasize that word, exactly. So let's start with the first scenario where my even digit is here in this position, the units digit position. Well, what are my even digits in terms of my possible choices? 0, remember 0 is even, 2, 4, 6, or 8. So that means I have 5 choices for this units digit. Now this guy cannot be even, right? Because I can only have 1 even digit. So that guy obviously has to be an odd number. So my choices are 1, 3, 5, 7, and 9. So I've got 5 choices. And very similarly, this one can also only be 1, 3, 5, 7, or 9. 5 choices. So I multiply these to get the total number, and that's 125. Now I've got 2 more scenarios. The next is when the even number is here. Well, if the even number is there, it's pretty much the same thing as what I just did. This is going to be 2, 4, 6, or 8 as possible choices. And these guys, 1, 3, 5, 7, 9, and 1, 3, 5, 7, 9. So 5 possible choices for that, 5 possible choices for that, and again, 125 when you multiply them all out. Now this is slightly different because you might be tempted to think this scenario is identical. It's not. The reason is because now I want the even number to be here. And if the even number is here, I cannot put a 0 because if I did, it's not a 3-digit number. It's a 2-digit number. So I can only put either 2, 4, 6, or 8. And then these ones are the same. I can put 1, 3, 5, 7, or 9. So the number of choices for the first first digit, which is the hundreds digit, 4 this time. But then for the tens digit and for the units digit, it's 5 and 5. So this is slightly different. This is 100. So the total, I have to add these three guys, 125, 125, and 100, is 350. So the answer for number 19 is A. What is the largest positive integer n that satisfies n to the power of 200 is less than 3 to the power of 500? Now I actually did this with logs and it works out beautifully. But this is a grade 10 contest. I'm not sure if logs are taught in grade 10. I knew about logs, but I'm different. So let's just do it without logs. And it can be done pretty simply. First and foremost, let's just write out the inequality. And what I want to do is make this simpler, and I can do that by just taking everything to the 1 over 100th power. If I do that, I get n over 2, or sorry, n to the power of 2, right? 200 over 100. And then this one becomes 3 to the power of 5. Yeah. So as you can see, this is completely valid, and it's much simpler. Now, 3 to the power of 5, you can easily figure that out, is 243. So n squared is less than 243, and therefore n has got to be less than the square root of 243, which is approximately 15.5. And therefore, since n is less than 15.5, the largest integer value for n is 15. So number 20, the answer is C.